Record. Good morning, guys. Welcome to almost half of the partial. Already half of your partial, almost. Well, today is January 24th, 2022. Remember to leave an empty space. And on the right top corner of your notebook, of your grid paper notebook, you place the date. Like I said, January 24th, 2022. What are we going to see today? Well, just like usual, some definitions. The first definition that we're going to see, because we're going to continue to work with equations, something related with relations and functions, okay, like really related, is the topic that we're going to see today. So, what is the solution of an equation? Solution of an equation. Well, the solution, sorry?
Another pair that makes such an equation a true statement in a solution of the equation.
Yeah, exactly, but you are reading the book, so you need to like think about yourself. So it is an order pair, just like Carlos Luis is saying, it's an order pair that will make true, we'll make a true statement. We'll make a true statement. And an equation, okay? So any order pair that makes an equation true, that would be part of the solution of the equation, okay? That's the first definition. Our second definition, give me a second, oh my God. Second definition that we're going to see today is linear equation. So we have seen already what is an equation. We said that an equation is a statement, right? A mathematical statement. You remember that definition? So linear equation. So it's still a statement, okay? In this case, it's still a statement. It is an equation whose graph, because in this case it is a graph, whose graph is a straight line. Okay, because it could be any line, but in this case, it is a straight line. That's why it's linear equation. Linear gives you a line, it has to be straight, okay? Because remember, you can have like curved lines like this. It's not a curved line. We're talking about a straight line, okay? And it's a linear equation. That's a linear equation, easy peasy. Okay, so how are we going to solve linear equations? In this case, we are going to solve linear equations with an input-output table. And what is an input-output table? An input-output table is a table that will help find values of a dependent variable by given values to an independent variable. So what does it mean? It means that we are going to have equations with two variables, okay? So let's say that, equations with two variables. These are linear equations. Okay, they are linear equations. This will have a dependent and an independent variable. The dependent variable usually is the variable y, and the independent variable, it is usually the variable x, okay? So we're going to give values to x in order to find the values of y using an input-output table. So it is a table that will help find values of a dependent variable by giving values to an independent variable. Here we're gonna add one more thing. It is a table that has at least 3 columns, okay? And we will usually use the domain -2, -1, 0, 1, and 2. We will usually use those values for the independent variable in order to find the dependent variable. We will always be using all of the rules for solving an equation, okay? Always, 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 we will be using that. Okay, so let's begin with an example for this type of linear equations, okay? So let's say that we have, we're gonna call it over here, examples. Okay, examples. So the example number 1 is gonna be the equation y is equal to 2x plus, 2x plus 1. That is your equation, okay? Now, we're gonna draw our input-output table. So, column 1, column 2, and column 3. Over here, we're gonna place the values of x, which are the domain. Over here, we're gonna place the values of y. And we can add a new column, okay? We can add a 4th column. And in that 4th column, we are going to have our order pair. The order pair, x, comma, y, okay? What are we gonna have in the middle? In the middle, we are always going to have the equation, okay? In this case, we're gonna have y is equal to 2x plus 1. Depending on the equation that you're given, that's the equation that you're gonna place on the 2nd column. So the 1st column is always the domain, which is the values of x. The 2nd column is the equation. The 3rd column is the range, meaning the values of y that you're gonna find with the middle, with the 2nd column. And the 4th one, if you want, and it's not necessary, you can write the order pair that you get, okay? So over here, I just told you, -2, -1, 0, 1, and 2. I'm gonna go one by one. So -2. What are we gonna do? We are going to substitute. Instead of x, I'm using the value that x is given. So I'm gonna say y is equal to 2 times -2 plus 1. And I'm gonna solve this, okay? So y is equal to 2 times -2. -4 plus 1. I choose -4 plus 1. -3. So that answer is the one that I place over here. You can say y is equal to -3. And you place that answer underneath the y. Now, what's the order pair? Well, the order pair is going to be -2, comma, -3, because those are the two values that we got over here. And that's the first one. Now we go with -1. Instead of x, I'm placing -1. So y is equal to 2 instead of x, -1 plus 1. And I solve. Y is equal to, how much is 2 times -1? How much is 2 times -1? -2. And -2 plus 1. -2 plus 1. -2 plus 1. -1. So y is equal to -1. And that's the value that I'm going to place over here. And my order pair is going to be -1, comma, -1. Okay, the next one. That would be with 0. Okay, we're going to move this a little bit higher. We're going to extend that line. Okay, so with 0, we say, okay, y is equal to 2 instead of x, 0 plus 1. 2 times 0, this is 0. It cancels out. We can cancel it out because any number multiplied by 0 will always be 0. Okay, so what do we have? We got y is equal to 1. So we place the 1 over here. And our order pair is going to be 0, comma, 1. Now we go with 1 because we usually going to use those numbers, -2, -1, 0, 1, and 2. And we're going to substitute. You see, it's a pretty long process, but it's easy. We're going to say 2 instead of x to 1. So 2 times 1 plus 1. 2 times 1. 2 plus 1. 2 plus 1.
3.
3. Okay, so we're going to place that 3 over here. And our order pair is going to be 1, comma, 3. And the very last one is with number 2. So y is equal to 2. And instead of x, 2 plus 1. 2 times 2.
4.
4. And 4 plus 1.
5.
5. So my last point will be 5. And my order pair is going to be 2, comma, 5. This is the input-output table of this linear equation. What are we going to do now? Now we're going to graph it, okay? So I'm going to graph my line, my coordinate line. Remember, line over line. Really straight lines using ruler. Some of you didn't use ruler on the last classwork. Okay, some of you didn't use a ruler. This is x. This is y. And if you want, you place a number. If you don't want, that's okay. So I'm going to grab the first one. -2 on the x. So -1, -2, -3 on the y. -1, -2, -3. That's my point. This one. -1, comma, -1. -1 on the x. -1 on the y. I'm going to place the numbers, okay? The little lines. At least those. I'm going to place them, okay? And I'm going to place here -1. -1 over here. positive 1 over here. And I think I need to make this longer. And 1 over there. Okay, let's continue. I grabbed this 2 already. Now 0, 1. Remember when I have a 0 at the beginning, it means that it will be on the y-axis. Then 1, 3, 1 on the x, 1, 2, 3 on the y. And the last one, 2, 5. 2 on the x, 1, 2, 3, 4, 5 on the y. I graphed the 5 points. And what am I going to do now? I'm just going to connect all of those points with a straight line. Let's see if I can connect it at the something like that. You're supposed to use a ruler, okay? I didn't use a ruler right now. So there it is. That's the straight line that we graph with this linear equation using an input-output table. This is method 1 that you can use to graph. We have like 2 more methods on how to graph this type of linear equations. Easy peasy breezy, right? Do you have any question whatsoever about this? No?
It's not a question, but you can put like the definitions second, please.
Work.
Just to take a photo.
There you go.
Thanks.
You're welcome. Now, what is the topic's name? Topic's name will be equations with 2 variables. So we can change this equations of 2, we can change it with. Okay, equations with 2 variables. And that is today's topic. Equations with 2 variables. And this is the type of graph that we're going to get with an equation of 2 variables using an input-output table. It takes a long time because we have to find 5 values of 5 equations. When you get to be like more an expert on this topic, you can use only 3 points, or you can get to use only 2, okay? But you need to become an expert first. Right now, this is the easiest method, like they say la vieja confiable, on how to graph. And this method is used in graphing any other type of equations, such as circles, okay? You can use it to graph a circle. You can use it to graph something that's called absolute value, okay? So this method is the method, like the primary one that will help you solve and graph any type of equations. Are we clear with this? So far, we're going to use always the domain -2, -1, 0, 1, and 2. Unless I give you another domain. That's the domain that you're going to use. If I say, okay, guys, you need to graph y equals -4x plus 3. And I just say that. Remember that the values of x that you're going to give are -2, -1, 0, 1, and 2. Unless that I say, use the domain -1, 1, 3, 5, and 7. Okay? Unless that I tell you, that's the domain that you need to graph. Is there any other question whatsoever? No questions. Are we clear? Okay then. So basically, this is today's topic. We are going to continue to practice in our next class, so don't worry about that.